Good morning. So we're going to review for our test. So the Pythagorean theorem, remember if you have a right triangle, then you can find the sides, okay, of a right triangle by saying a squared plus b squared is equal to c squared. Okay? Okay, so let's try to find here. I have my two legs. One is 6, one is x, and my hypotenuse is 17. So I can find that leg. Okay, so I would say 6 squared plus x squared is going to be equal to a 17 squared. So 6 squared is 36. 17 squared is, what, 289? Subtract 36, so you'll get x squared is equal to 253, and then we take the square root of that. So then we'll take the square root of both sides. So x is going to be equal to a decimal. It's almost 16, but what, 15.9? Okay, let's do another one here. So this is not perfectly drawn, but imagine that this is an equilateral triangle. Okay, if this is an equilateral triangle, and I want to find x, and when I find x, it's going to be the height right there. Okay, so if I tell you that my equilateral triangle, that this side over here is 24. Okay, how am I going to be able to find that x? Okay, so, well, the equilateral triangle means that all my sides are equal. Okay, so this side, this base down here, is going to be 24. Okay, but the height right there is going to split it in half, so that means this side is going to be equal to 12. Okay, so I can find this by saying x squared plus 12 squared is equal to 24 squared. So x squared plus 144 is equal to, what, 576? Subtract 144, so you get 432. And then take the square root of both sides. So x is going to be about 20.8. Okay, so let's do an application. So a 20-foot ramp is used at a loading dock of a factory. So we have a ramp, that is 20 feet. Okay. If the base of the ramp is placed 19 feet from the base of the dock, okay, how high is the landing dock? So what I'm looking for is going to be this distance right here. So you can say x squared plus 19 squared is equal to 20 squared. So x squared plus 361 is equal to 400. Subtract. So you'll get x squared is equal to 39. And then take the square root of both sides. So x is going to be equal to a 6.2. Okay, so the other thing that we learned was talking about classifying triangles. So we have a right triangle when c squared is equal to a squared plus b squared. Okay. If c squared is greater than a squared plus b squared, then it is obtuse. Okay. If c squared is less than a squared plus b squared, then it is acute. Okay, so let's look at this one. 9, 15, 19. Okay, so remember that the first thing that we have to check is that the two sides, the two small sides, have to be greater than the large side. Okay, and so that is true. So what, 9 plus 15 gives you what, a 24? So 24 is greater than 19, so that's good. We have to just check that that could be a triangle. And then we're going to take my largest side and I'm going to square it. And then I want to figure out what it is. So 9 squared plus a 15 squared. So 9 squared is an 81. And 15 squared gives you a 225. Okay. And 19 squared is 361. So 81 plus 225 is 306. So 361 now is going to be greater than 306. So that means that this triangle is going to be an obtuse triangle. Okay, let's do one more. So here, remember, we just need to check. So my smallest sides, 3 plus 5, have to be greater than 18. Oops, that's 15, I'm sorry. So what is that? That's 18. Is 18 greater than 18? No. So this is not a triangle. Okay, so the other thing that we talked about was special right triangles. Okay, so in that special right triangle, we had one triangle that was a 45, 45, 90. So that means my two legs were the same. Okay, two legs would be the same, and so my hypotenuse side would be my leg times the square root of 2. Okay, and a 60, 30, these are not drawn to scale, I'm sorry, so 60, 30 degree triangle, so 60, 30, 90, okay. Across from my 30 degree will be my shortest side, so it would be my x. Across from the 60 degree side would be x times square root of 3. And then across from the right would be 2 times x. Okay? So there are some ratios for you. Alright, so I'll say this example here. So here we're looking at a 45 degree angle triangle. And so I want to find my x and my y. I know that my hypotenuse is 22. So my hypotenuse is 22. So it should look something similar to that over on that side. So what I'm going to do is I'm going to say 22 divided by the square root of 2. Okay. So remember, we don't like square roots in the bottom. So what I'm going to do is I'm going to multiply both things by the square root of 2. So I'm going to get 22 times square root of 2 all over 2. 2 goes into 22, 11. So this is going to be 11 square root of 2. Okay. Another way to think about this is 45, 45. So x and y are going to be the same number, right? So really I could change this into another x. So that would mean what? X squared plus x squared is going to be equal to a 22. So that's going to be a 2x squared is equal to a 22. Yes? Okay. Sorry. Need to square that, right? Alright, so 22 squared is going to give you a what? 22 times 22 is a 484. Okay, 484 then divided by 2. So this is going to give you an x squared is going to be equal to a 242. And then I would take the square root of both sides. So then the square root of 242 is going to give you an 11 square root of 2. Okay? So there's two ways to think about it using this special triangle. Okay? Okay, so let's do another one. Trig ratios here. Remember, we can find, if we're looking for an angle, we could find a ratio of the sides. So remember, if you're looking at angle A, so I'm going to be looking at angle A. So I could say sine of angle A is going to be equal to the side opposite over the hypotenuse side. Cosine of angle A is equal to the adjacent side over the hypotenuse side. Tangent of angle A is equal to the side that's opposite of angle A over the adjacent side. Okay, if you were changing this and going to look at angle B, then same thing. So sine is the side that's opposite. So the opposite of angle B is going to be side B over the hypotenuse. Cosine of angle B is going to be the side that's adjacent. So this is going to be A over your hypotenuse. And tangent of B is going to be opposite over adjacent. Okay? Okay, so here. Let's find all of the trig ratios with this triangle here. So before I find all the trig ratios, I need to find this opposite side here of B. Okay, so it would be x squared plus 12 squared is going to be equal to a 20 squared. So that's 144 is equal to a 400. So 400 minus 144 is equal to a 256. Square root of 256 is going to be a 16. So x would be equal to a 16. So this side, this remaining side over here is going to be a 16. Alright, so what I want to find is I want to find sine of A, cosine of A, and I want to find tangent. I just want to find the ratios. Okay, I'm not looking for the angle A, I just want to find that. Okay, I want to find sine of A is going to be equal to something. So sine of A is going to be my side that's opposite. So 20 over 20. 12 over 20. Cosine is going to be your adjacent side, so it's going to be 16 over 20. And tangent is going to be 12 over 16. So the side that's opposite over the adjacent. We can reduce those. 12 can reduce down 12 and 20. 4 can go into both of those. So that can reduce to a 3/5. 16 over 20, 4 still can go into both of those. So it's going to be 4 over 5. 4 can go into both of these. 12 over 16 there. So 4 goes into 12 3 times. And 4 goes into 16 4 times. Okay? Okay, so let's do another example here. So here I want to find x. Okay, so I want to find x by somehow doing a trig ratio. Okay, so what I know is that I know my hypotenuse, right? And I know the side that is adjacent to the angle. So that is cosine. So I can say cosine of 42 is going to be equal to x over 15. Okay, so multiply both sides by 15. So 15 times cosine of 42 is going to be equal to your x. Okay, make sure your calculator is in degree mode. So cosine of 42 times 15, so it's going to be 11.1. Okay, so the other thing that we have done is law of sines and law of cosines. So with the law of sines, remember it's a ratio of your sides and your angles. So mostly you are going to know two angles inside of a triangle. Okay, so let's say that you know A and B. Okay, well, let me make this capital. Okay, so let's say you know angle B and you know angle A. Okay, and you know the side that is opposite of angle A and you know the side that's opposite of angle B. Okay, so then we can say sine of angle A over side A is equal to sine of angle B over side B. Okay, so mostly when we use law of sines, we will know two angles inside there, or we can find the angle that we need. Okay, law of cosines, then inside your triangle, you may just know one angle inside of your triangle. Okay, so let's just say that you know angle B up here. Then you're either going to want to find the side that is opposite, okay, and then you know maybe the other two. Oops, I cannot get my letters and numbers straight today. Okay, so what we would do here is we would say B squared is going to be equal to A squared plus C squared minus 2AC times the cosine of that angle B. Okay, so we can flip-flop this around. So whatever we're trying to find right here, if we're trying to find this side right here, okay, and we know this angle up here, okay, if we know this angle, I don't know, is, I don't know, 15 degrees here, and we know these two sides, then what do we have? I'm trying to think of something for you. 30 and 12. Okay, then we can plug that in. So we would say x squared plus 30 squared plus 12 squared minus 2 times 30 times 12 times cosine of 15 degrees. Okay. Okay, laws of sines. So same situation here. Okay, law of sines. If we know those two angles right there, let's just say that one is 74 and this one is 16. Okay, and we're trying to find this side and the one across from 74, I don't know, let's say it's 26. Okay, so we can say sine of 74 over 26 is equal to sine of 16 over your x. So that's how you'll use your law of sines and law of cosines. Okay, all right, so that's everything that you need to know for your test. Application problems too that go with all your triangles, and also law of sines and law of cosines. Okay, hope you'll have a great day.